Okay, explain further. Please sit down. Please sit down. We had completed the road cycle. So, okay. Discuss use of convex. Heated already. Street lamps and real units. We have done this already. Yes. Okay. Anyway, let's consider again. Street lamps and here is. Yes. Are you sure we have done this? No, I think you've done it in school and you please that. Eight uses of on-care, not functions. Chalo, ठीक है, anyway. So anyway, we have noted it here. So anybody has any difficulty in understanding these uses? So what should happen in street lamps? Focused. Do we need focus light like vehicle headlight? We need spread out, right? So how will it spread out? This is the, let's say, this is a convex here. Okay. So if we keep the light over here, right? Let's say this is the source of light. The source of light travels in this direction. What should happen? Like this, right? Likewise, it will go back and go straight. This is what is expected in a straight line. And what about rear wheel mirrors? Likewise, if the viewer is driving ahead, let us take the direction. So we see this real objects. Okay. Real objects spanning large area, only visible to them. So you will see it as a small image, right? But then you'll be able to see a very large area. Yeah. This is okay. This is the next topic. Sign conventions. So, are you familiar with the Cartesian sign conventions or graphs? Graphs is Cartesian. Okay. So, what is y-axis? Your graph. That's where you will keep your mirror. Okay. And on x-axis will lie your object and images. Okay. So basically, on the y-axis, that's the mirror. So the pole of the mirror is actually the origin. Pole is basically origin. Okay. So pole is the origin. Then what happens in XY? All the distances on the right of the origin are positive. Okay. Everything to the right, whether right above or right below, everything this side is positive. Everything to the left of the origin is negative. Same sign convention as the graph or Cartesian plane. Okay. Then what is above? Positive y-axis. Okay. Anything above the principal axis. What is y-axis here? Principal axis. So both sides, anything above is positive. Anything below is negative. Okay. So now let's understand. So case of concave mirror. Okay. Focal length case of concave mirror. Where is the focal length of concave mirror? This side. Okay. So all distances will be measured from origin, pole. Focal length is positive or negative. For concave mirror, focal length is, what did we say? All distances to the left of P is negative. Okay. And will parallelly write for compression. In case of convex mirror will be what? Where is the F for convex mirror? For convex mirror, it's like this. Okay, I'm not drawing it, but you understand. The center of curvature and focus is on the right side. Okay, so it should be positive. Very important, right? Now, so your focal length. Then you have. No, we are discussing sign convention for mirrors. So in numericals, it's very useful. So in the numerical, they will not give you the sign. You have to guess from the given data. So even though some numbers will be given to you, what you have to apply, present that number with sign. These rules are applicable there. We'll learn it with the help of example also. Yes. So what are the other distances? Object distance. What is U? Have I told you what is U, F, and all? Okay, let's just write down. So F is focal length. U is object distance. E is image. Okay. Now U always is in front of the mirror. What is front? Front is this side is front. This is behind. Right. So always the real image is in front of the mirror and it is below the principal axis because real is always inverted. Okay. Virtual is always on this side. So once you remember all this, it's very simple. So these are images, right? Now in concave mirror, the first time you go for the object distance. So object will always be negative, both for concave and convex mirror, because object is always kept in front of the mirror. Okay, what about image? For concave mirror, you have all kinds of images, real and virtual. So it depends, right? So for real, it will be negative. For real, positive for virtual. So you have to be careful. Each sign will be positive or negative depending upon what kind of images Where is the object kept? See the ray diagrams. Where have we kept the object? AB.
Yeah.
Always in front of the mirror. Where is it? From P, it is on the left. That's why. Whether it is convex mirror or concave mirror, always object is in front of the mirror. So it is always negative. Clear? Achha. So what about B for convex mirror? Always positive. Huh? Here, practice ray diagrams. So for what? Very good. But the video lectures are there, no? Why? We're discussing physics lecture. Was it not available in the? You see that because it's a long class, 1 hour. You can't clear it as doubt. You have to go through that lecture fully. Still, you have some doubt in us. Okay, right now, pay attention because if you are, everything will be a doubt for you. You miss one class. Did you miss last class or the class before? Last class. That's where we discuss all this. Okay, so just pay attention. So here it is going to be positive because there is virtual image in the first quadrant, real in the third quadrant. Okay, always remember. So if it is above principal axis, virtual will be upright. It is not inverted. Real is always inverted. So we covered these distances. What else? R and F sign will be same, right? Because F is R by 2, correct? Here also, R will be positive. Again, height, yes. So height of the object, height of object is H. So H in this case is what? Always positive. Because object is always kept above the principal axis. So H is positive. Positive. H dash is height of object, AB. Huh? R is radius of curvature. F is equal to R by 2, remember? Radius of curvature, CP. So this is negative. When is it negative for real? Positive for virtual. Because concave mirror has both kind of images, right? Here H dash is so P H dash is always positive. Right. Okay. Virtual image. Case of concave, we have both kind of. So here I'll write a note. What is H? Object size. Dash is H dash. Incident light. That doesn't make much sense. We just say all distances to be measured from pole. All distances to be P right of P, above P, below P. So this is like above P. Wherever, anywhere on the principal axis, above P is positive, below P is negative. Left is negative, right is positive. Isn't it? So if you, then there are two more sign conventions. One is magnification or concave and convex. Before that, we will learn about mirror formula. So right now you just write down the magnification. I'll explain it later what it is. So M for real negative, for virtual positive. M is magnification, negative for real. Yes. So you will see that it is similar pattern. Virtual. M is magnification. Okay. I'll explain it in a minute. Okay, so it is positive. What is that? I write it for them. M is called magnification. Magnification is the size of the image with respect to size of object. That ratio. Okay. That's magnification. How big is the image obtained with respect to the object size? So if you remember the sign convention, which is very easy, you can never go wrong. The mistake happens in optics numericals is the sign. Rest is just algebra for pure mathematical sense. If you get the sign wrong, then the answer will be wrong. Okay. Any questions, online student, regarding the sign convention?
No, sir.
No, sir.
Can we switch off this fan? So it's shaking for them. That is your. It's the again okay. पीछे का फैन चालू करो कर दे चालू पीछे का नीचे है ठीक है last is it does not fan Okay, shall we proceed? The next is going to be mirror formula is a relation between F, U, and B for the given mirror. Okay. So right now, mirror formula. Relation between F, U, and B. Okay. As given. It is 1 by F is equal to 1 by U plus 1 by U plus 1 by V, or it doesn't matter. 2 plus 1 by. This is called mirror formula. So note, while solving numericals, substitute the given data with appropriate sign. Okay. Keep the calculate the unknown variable. Without so you have to leave the unknown variable as it is. So give the sign of only the known data. Okay, we'll understand the help. I think you have to get used to it. I don't know why it's taking so much. Okay. Okay. Next is magnification. Can I erase this part? Yes. Magnification. Now this formula will be deriving in higher classes. Right now you will have to just take this approach. Okay. Group is not in the scope. Magnification. Same for this. It is the comparison. It expresses. It is given as the ratio of size. It is also equal to minus B upon U. It's a 2-in-1 equation. Okay. It is basically ratio of image size to object size. Its length becomes equal to minus B by U. And like this, you have to just take this form. I think we'll take up some examples on Miller formula and magnification before moving on to refraction of light. You have the NCERT textbook. You have NCERT textbook downloaded here. I'll write down the given data. It's example 10.1 in my book. In the new book, the chapter number has changed because some chapters have been deleted. Anybody has NCERT textbook? What's example 10.1? After the end of this topic, magnification, there is an example. Just give me what is the number and what's the page number. Is this chapter 9 or 10? Chapter 9. And what's the page number? For example, 9.1. We are doing example 9.1. Page 144. So just go home and check it. If you have the old book, then it will be example 10.1. Okay. The new book. You are using your elder brothers or sisters book, it will be 10.1, page 170. See, so much video syllabus here. Again, the old book. Why is new generation consuming less knowledge? Or is it that the old generation consumed all bad? All right. So I'll read the example for you. A convex mirror used for rear view on an automobile has a radius of curvature 3 meters. Okay. So all the given data we'll write first. You will also write the name of the mirror. What is it? Convex. So then you will decide which sign convention to use. So given it is a convex mirror. And its radius of curvature given in the numerical is 3 meters. So for convex mirror, it has to be plus 3 meters. If a bus is located at 5 meters from this mirror, that means the object distance is given as 5 meters. Now in the question, it just says 5 meters. No sign is given. But you have to put a sign because U has to be always minus. This is what I was saying. Okay. So here object distance is given as just 5 meters in the numerical. You have to put minus the applicable sign command. Find the position, nature, and size of image. So you have to find the position. That is image. Then the nature of image. Full to what? Then size of image. The size of image is h dash equal to these three things you have to find. Okay. So solution. Now since R is given, what do I need? I need to find V. So I need to find V. I have U. So I need F. So since I know R, so this will give me F is equal to R by 2. This is equal to 3 by 2. 1.5 meter. Okay. This is what we read. So solution. Why error formula? One by two plus 1 by e. Okay, I read this side. Therefore, 1 by e is equal to 1 by f minus 1 by e. So for v, we are not substituting any sign. We are just keeping as it is because this is the unknown variable. So we keep v as it is because we don't know where the image is going to form. But since it is a convex mirror, we know that v must be positive. Where will be its image? In the first quadrant. Correct? Virtually one time. So this is how you can cross verify. Because it is convex mirror, its image has to be positive. So 1 by v is equal to, what is 1 by f? So this is 1 by 1.5. Or you can keep it as 3 by 2. So it will be 1 by 3 by 2 for easy calculations. And this is minus 1 by minus 5. Okay. This is where a lot of mistake happens. Okay. So now you rationalize and solve. This will be 2 by 3 plus 1 by 5. How much is this? 7 by 3. Okay. So this means E is equal to 5 3s of 15. Right? 1 second. 10 plus 11. Shortcut मत करना भाई plus 3 plus 5 3s of 15. Don't go for shortcut, okay? So now this is 15 by 13. So this is equal to 13 upon E. Therefore, E is equal to 15 by 13. What was the this is meter? Yes, everything is given in meter. So find out how much it is. 13 ones up. 10, 20. Again, one time. 70. How many times now? 5 times. 70. How many times? 5 times. Nice. So this is what, and we were expecting it to be a positive value. We got a positive value. Clear? So we found V. So nature, since V is positive, image is virtual. It is behind the mirror. Yes. So behind the mirror will be virtual. Since V is positive, nature of images is virtual, and if it is virtual, it will also be right. So we gave nature also. Now we have to find H dash, right? How do we find H dash? So we use this part. We have H. Is the size given? No. So we find H dash in terms of H. Okay. So we have V and we have U. Next. So this next. Since H dash upon H is equal to minus V upon U. Therefore, H dash is equal to minus E by U into H. So what is D now? We will keep D as fraction, minus 15 by 13. And what is U? U is minus 5. Everywhere we have to substitute U with sign. U was minus 5, right? This minus minus is cancelled. Here 5 3s are 15. Right? So therefore, H dash is equal to 3 by 13 times H. Now you are expecting that the image size must be smaller than the object size because it is a convex mirror. So for convex mirror, it is always smaller. It is diminished, which is okay. So when the magnification is less than 1, then the image is smaller than the object size. Okay? So it is on the expected line. So how much 3 by 13 is? So this is equal to 0.32 times. Okay, so 26, 4. How much it will be now? 33 times. 0.223. Okay. So therefore, image size is 23% of object size. Okay, image size is 23%. Or image is virtual, erect, and smaller in size by a factor of 0.23, whatever. So you get the idea that the image is like less than 1/3, less than 1/4 even. 1/4 is 25%. This is 23. It is little smaller than 1/4. Whatever. So did you get the idea how to use the sign convention? Okay. So likewise, you can try the next question. It's similar. We'll go to the in-text question. There is an in-text question on page 145. We'll do question 1. There are only 2 questions. Do not leave any NCERT questions. Attempt all solved examples as well as behind the exercise question. Do not leave any question. Okay. And more question from wherever you can. Get into reading too many reference books. First, thoroughly finish NCERT. Again, there are enough questions for you to understand the concepts. Once you are done with it, then you can go to additional references. Okay? Because there's no point wasting too much time finding out, going to the reference site and getting bogged down. So do everything what is given in NCERT, and we'll have so many practice tests. We'll be well prepared for the exam, so don't worry about it. Okay? All right. So the question goes like this. Find the focal length of a convex mirror whose radius of curvature is 32 centimeters. Just divide by 2. And is it will be plus or minus? Convex. Positive. So I also get confused. So it's normal, okay? So that's why I draw so many ray diagrams. Okay? Convex, convex is like this, bulging out. So this side is reflecting surface, towards you is coated. Yeah, ऐसे देखना तो ऐसे देखो. This is convex. Spoon, right? The back side of the spoon is convex, reflecting surface, and this is convex. Okay, that one. Initially it happens. Yes, you're asking something. Anybody? Question 2. A concave mirror produces 3 times magnified real image Okay? A concave mirror produces 3 times magnified real image. Where is the image happening? Third quadrant. Concave mirror, right? So real in front. So third quadrant. An object is placed at 10 centimeter in front of it. Where is the image located? Where is the image located? So you have to calculate it. Right? So this is a good question. Let's do it. What is given? So this is in-text question. Two. Okay, K is 145 or 146. 145. Okay. So what is given is concave mirror. So it produces 3 times real image. So what is given is magnification. 3 times real image, so it is -3. If it is concave mirror, and if the image is real, then magnification has to be -3. It is given like a word 3 times. So you understand that it is magnification of an object placed at 10 centimeter. ठीक है? तो यहाँ पे हमने ये sign I have put it. Unless you put this sign. So where is the image located? E is equal to so it is a real, so image has to be in front. You expect B to be negative. Correct? Because it is concave mirror and it says magnification -3, you have to understand that is image is real. So from the given data also you should be able to infer. Okay, so now solve it. So what is the relation between M, U and B? Since M is equal to -B by U. So therefore, that is -B. This. It is on the expected lines. Okay. The real and enlarged. Fine. Till here, anybody has any questions? Okay, so now we are ready to deep dive into the refraction of light. Anybody? What is the refraction of light? Any idea? Okay, give them chance. Yes, go ahead. Online.
The refraction is the bending of light when it changes the medium, like when it goes from the air to the glass, it bends.
Okay, so in general terms, whenever light passes from one transparent medium to the other transparent medium, its direction changes. So this change in direction, when it goes from one transparent medium to other transparent medium, is called refraction of light. What is the reason for change of direction? Yes, because the speed of light is different in different mediums. So if you remember, we had discussed that speed of light in vacuum is how much? Yes. It is different in different mediums. You know this. So in air and vacuum, how much it is? Air and vacuum is 3 into 10 raised to 8 meter per second. In any other medium, it is less. It is less than. This symbol is C. Less than C. Okay. So due to this, the direction changes. What it has got to do with direction? What speed has got to do with direction? Like if I'm running, if I slow down, I still will travel in the same direction, right? Is my medium changing? Is my medium changing? That's why. But if I'm running and suddenly there is a muddy surface, hard surface and suddenly a muddy surface, then I may get unstable and my direction might change. So for example, let's say there is a car. So let's say this is the road, right? This side is the pavement. This is a muddy pavement. Okay. So as long as the car is traveling on the road, imagine a Formula 1 kind of a car. Okay. So as long as it is on the same surface, it is traveling in the straight line. Now imagine in a situation, something happened and two of its tires came here and two are here. Where will it be traveling at a faster pace? On the road. This tire must slow down because friction increases. This is muddy pavement. Okay. More friction here. So this is slowing down and this is fast. So now it will turn something like this. So when the medium changes, there will be change of speed. And change of speed does lead to change of direction. So this is the closest analogy I can give you. Okay? So this is what happens with light. Now car is a very big object. Light is very small. Okay? So what do you do? What happens is, so this phenomenon is called refraction of light. Okay? So what is the refraction of light? Let's formally define it. So whenever light passes one transparent medium, the transparent medium it's other transparent medium, its direction changes the second medium. Yes, what is the doubt?
So the speed of light and characteristics and speed of light.
In air and vacuum, it is minutely different. minutely less. It's like 2.999 something. So that's very close. In air. Huh?
We cannot count that.
No, we can count that, but we ignore it because the difference is so minor between air and vacuum that we say that it is same. So it is fastest in vacuum, slightly less in air. Okay. So ideal case is that's why this value is only in vacuum. In air it will be little less. But for switch, yes, is it sorted? The change in direction takes place difference in speed of light is different. This reason is asked why the direction of light changes is because of this. So this speed you have to remember 3 into 10 raised to 8 in vacuum or air is a standard constant. You have to remember that. Now, which way it will bend? यहाँ पे लिखना था this is called this. Now मिला. It's called refraction of light. Okay, this change of direction whenever in a pair of media light changes direction in the second medium, it is called refraction of light. How which direction it will bend is here. If the second medium is called refracting medium, where the direction changes. Is denser than the incident medium. First medium. First medium is called incident medium. Okay. If the second medium is denser than the first medium, then the refracted ray bends towards normal. All this will become clear in just one diagram. All of this. And vice versa. Yeah. That is away from it. The basic rule. Okay. If you understand that, most of it. Okay, so I just ignore this whenever. Okay. The flow, the right process. Friends, in speaker of light, if the second medium is denser, the first medium. So before denser, you put optically denser. Okay, then the first medium. Lines towards from the second further. So again, rarer is optically rare. Okay, once I use it, so rarer or denser is in terms of optical density. Okay. So let's understand it here from a diagram. The most common transparent mediums you will encounter are air, water, and glass. These are the only three things. Okay, then you have kerosene, etc. These are three transparent mediums. So let's draw a pair of medium. This could be water or glass. This is a denser medium. Let's write this as first, this as second. And this is the boundary separating the two mediums. Let's call this as AB. Here, let's draw the normal at this surface. So whenever we are studying reflection or refraction, okay, normal is key to our understanding of how the reflection or refraction is going to take place. Okay. Is going to take place. So let's say there is a ray which is incident in the first medium and it hits the boundary of the second medium at this point, say O. That's it, O is the boundary. Right? So this is air, this is glass. So which way the ray will go? This is the original direction. Which side it should bend? Towards normal or away from the normal? Towards normal. Because it is denser medium, right? So it will bend like this. So this is your angle of incidence. This is now angle of refraction. Okay. And this angle is angle of deviation. Okay. This is the angle of deviation. So now this incidence. Refraction. Delta. This is called delta, small delta. And draw deviation. Okay. Yes, sir. We will continue in the next class. Yes, small delta. What is big delta? Yes. Okay, I'll see you in the next class.